rename your profile name with the correct conventions. Okay, so I'll just start the recording. So good afternoon, everyone. We will start with OS day 4, which is the last day for your operating system subject. We have started with the introduction of OS, then we have seen process, you can see specifically into the process management. In case of process management, we have seen what is process control block, what do you mean by CPU scheduling criteria, different algorithms of CPU, what is PCB. Then after that, we have seen inter-process communication called as IPC. And then we have started with the concept of deadlock. And in case of deadlock, what are the necessary conditions for deadlock that I have explained. Now, also in the last class, we have seen something called as memory management, where we have seen what do you mean by memory, how the memory is managed, what do you mean by fixed partitioning, what is mean by variable partitioning. Also, we have seen the concept of memory allocation algorithms, or you can say allocation techniques, in which first fit, best fit, and worst fit that was being taught, right? In continuation with memory, first we will see in today's class what do you mean by memory management, different algorithms, and we will see what is paging, segmentation, and some algorithms with it. Later on, we will see something called as disk scheduling criteria. So this is the agenda for today's session. So let us quickly start with memory allocation types. Now, when you talk about allocation, we have seen two categories in the last class. One was single partition, another is multiple partition. When I say single partition means a complete memory is divided as one single block. In that case, we have seen there was a concept of variable partitioning. Later on, we have started multiple partitioning. That means fixed size partitioning of equal and unequal size. Maybe you are saying 100 GB, 200 GB, 200 GB, and so on. That is called as fixed size partitioning. And when we have seen something called as dynamic partitioning, in that case, we have seen three categories. One was first fit, second was best fit, and third was worst fit. In case of these partitioning, we were having a problem which is called as internal and external fragmentation. So if I'm saying I have a memory block, if that complete memory block is unused in between the memory, that is called as internal fragmentation. But if I have a complete memory block, and if some one block is allocated, and if within that block, if the memory is remaining unused, then that is called as external fragmentation. So internal and external fragmentation we have already seen in the last class. All these types were called as contiguous memory allocation, means जैसे ही memory allocate होगा वो continuous memory allocation होगा. That is called as contiguous memory allocation. And when you talk about non-contiguous memory allocation, it means one process and many pieces of memory. That means I have a paging and a segmentation. This is the technique which is used by operating system when I have a memory, right? And that memory is utilized by different processes, not in a continuous way. It is in the random way. That is why it is called as non-contiguous. And why do we go for? Because the problem in contiguous memory allocation was internal and external fragmentation. So we will see what is paging and what is segmentation. Whenever I'm talking about address types, अगर आपको नेटवर्क सब्जेक्ट याद रहेगा तो हमने दो कैटेगरीज नेटवर्क सब्जेक्ट में देखी थी. वन वाज फिजिकल एड्रेस which was also called as MAC address. Another is logical address, which is basically called as IP address. याद है सबको? Right? Now, IP address is basically used by us so that our machine can be understood to the network. MAC address is basically given to the machine which is physically available or physically printed on your NIC card. As far as your network is concerned, we were having these addresses. As far as your operating system is concerned, we have two categories also. The first is a physical address and second is a logical address. So when I talk about physical address, it is basically the exact memory location which is given to my any page or any process. A logical address is a reference to the memory location independent of physical structure or organization of the main memory. We will see, you will understand the difference between physical and logical addressing in case of paging now. I will guide you into that. So physical means actual physical memory. Logical addressing means मेरा system कुछ तो address use करता है. Maybe it uses some kind of offset. Maybe it uses some kind of base address and the offset. So you can say the base address is the address which is given to me for my pages or the processes. That is the actual memory allocation given to my process. When my operating system says I wish to go for some location, then it may use some kind of offset, some kind of limit, some kind of base plus limit, and so on. So in that case, that kind of category is called as logical address. It is a reference to the memory location independent of physical organization or the structure of the memory. This I will explain once again in case of paging. Let us understand what is paging first. I will explain with the help of this diagram. Then we will see the theory part. Suppose I have a process, right? Whenever I have any processes, those processes are divided into equal number of blocks. And those equal number of blocks are called as pages. Now, when I say this is my main memory, a main memory is divided into equal number of blocks, and those equal number of blocks are called as pages. Whenever any process comes for the execution inside the main memory, that process is loaded into different memory allocations. For example, considering this scenario, I have initial main memory as of 15 pages, 0 to 14. So I will say the capacity of my main memory is of 15 pages. Suppose there is a process A which comes and process A wish to execute. And if the process A wishes to execute, in that case, process A is saying, I need 4 pages. So based on the allocation, my operating system will allocate 4 pages to the process A. Now, every memory is basically divided into number of pages. So I will say I have 0 to 14 pages, out of which process A says I need 4 pages. So process A is allocated from 0, 1, 2, and 3. Assume process B comes and process B says I need 3 pages. So process B is allocated page 4, page 5, page 6. Again, process C comes. Process C says I need 4 pages. So page 7, page 8, page 9, page 10 is allocated. So I have 3 processes as per their requirement. Memory blocks or memory pages have been allocated. Did you all understand up to this diagram so that I will go little ahead? Everyone? All right. Now, when I say, suppose now B process is swapped out, right? If B process is swapped out, in this scenario, can I say these 3 blocks will be empty because it is swapped out from the main memory? And if it is swapped out, I have A and I have C. Now in this case, when suppose process D comes, assume, and process D is saying, I need 5 pages. What your operating system will do, D0 will be loaded here, D1 will be loaded here, D2 will be loaded here, D3 and D4 will be loaded here. Can you observe the memory is given in a non-contiguous manner? That is called as pages. But when I'm using pages, in that case, can I also conclude कि यहाँ पे मेरा external fragmentation नहीं हो रहा है? ये complete block is remaining unused, but जैसे ही नया process आया, मेरे operating system ने इसको allocate कर दिया. Can I say like this? There is no external fragmentation. Are you unable to understand, everyone? Now, but suppose अगर D5 प्रोसेस को 13th वाला भी पेज लगता था, that too partial, right? What I'll do, I'll take this over here to make you understand. I'll just copy this, right? And I'm saying, suppose D को एक और पेज लगता था, D.5 पेज. But what D is saying, I do not require complete page 13. I will require only this much data. So if I try to fill this as well with the same color, can I say block page number 13 is partially used by D5 and partially it is empty? Can I say like this? Right. Can you please tell me which type of problem is this? Which type of problem is this? Is it nothing but internal fragmentation? Of course, yes, it is an internal fragmentation. Initially, जब मेरे पास D0, D1, D2 नहीं था, at that moment, that block was empty. That was external fragmentation. But जैसे ही D process आया, D has been loaded over here. That means external fragmentation have gone. But if some process requires lesser than this block, then internal fragmentation may occur in case of your paging technique. Have you understood what is paging? जैसे प्रोसेस आता है उसको पेज टेबल उसको पेजेस को लोड करने का, and it is basically avoiding our external fragmentation. Now, how my operating system will come to know that process A requires page 0, page 1, page 2, page 3. Process C is loaded at 7, 8, 9, 10. Page D is loaded as 4, 5, 6, 11, and 12. It has to keep some track. To keep that track, your operating system manages something called as page tables. So what does the page table say? Process A page table looks like 0, 1, 2, 3. I'll take this and I'll show you this. Let me take this diagram little ahead, maybe over here, right? I'll remove this and I'll keep it over here. Now, by looking at the diagram, By looking at the diagram, can I say process A is loaded into this as a page number? Can I say this is the page number? Everyone, page number 0, page number 1, page number 2, page number 3. And every page table is given some index value. Okay, it is given some index value. Similarly, process B is now out of this and it is not having any page table. Process C is using 7, 8, 9, and 10. 7, 8, 9, and 10. This is nothing but page numbers and this is nothing but index which is maintained. Next, process D. Is it 4, 5, 6, 11, 12? Yes, and it is nothing but its index number. So, operating system maintains a page table for every process which is available in the main memory. And from that, your operating system will come to know, yes, this process is using this memory. Now, if I talk about specifically, let us say process A. My main memory pages are used as 1, 0, 1. Okay, I'll talk about process D. It will be easy for you to understand. My main memory pages are 4, 5, 6, 11, and 12. Am I talking about the actual memory pages over here? Are these the actual memory pages? Yes. So I will call them as physical address. समझ में आया? Everyone. Now, if I say for understanding, process D page frame number, comma, page number. Frame number or index number, however you say. Can I say 0, 4, 1, 5, 2, 6, 3, 11, and 4, 12? Everyone, have you understood up to this point? It means that this over here, this is called as physical address and this is called as a logical address. Means this is a logical address. You can say like this. I'll explain one more time. जब आप, मैं नेटवर्क में जा रही हूं अभी, जब आप मैक की बात करते हो, is the MAC is printed on NIC card? Yes, that is called as physical address. But जब आप logical address की बात करते हो, तो आप IP address की बात करते हो. तो there is some converter called as IP to MAC. इसलिए तो हमें एक्चुअली देखा जाए तो मेरा एक मशीन है, उसको एक मैक है, my machine is having IP. Are they the same, pointing to the same memory location, maybe the same host? IP and MAC, yes. Similarly, logical and physical addressing segregation के लिए होता है, but ultimately, are they pointing to the same memory location? Yes. If I ask you over here, I am considering my physical address, which is nothing but 4. So where it will point, this 4 is pointing to nothing but this memory location only, right? But if I ask you, go to process D and go to process D page 0 and tell me the exact memory location, how it will go? It will go to process D, it will go to page number 0, it will observe this is the physical address, and ultimately where it will go? Will it point to the same memory location? So here this is called as direct accessation of memory through physical address. This is indirectly I'm accessing it. तो जब मैं किसी भी लोकेशन को इनडायरेक्ट वे में एक्सेस करती हूँ, उसको हम बोलते हैं लॉजिकल एड्रेसिंग. I hope you have understood the meaning of physical and logical addressing. Everyone, right? I'll just save this diagram for your reference as a paging. So let us understand. Initially, your pages was this. The OS needs to maintain a page table for each process. Each entry of the page table consists of frame number where the corresponding page is physically located. The page number is indexed by page number to identify the page frame number. A free frame list is available. अब मेरे इस पर्टिकुलर मेन मेमोरी में 13th and 14th ये दोनों फ्री अवेलेबल है, तो ऑपरेटिंग सिस्टम मेंटेन्स अ फ्री फ्रेम लिस्ट फॉर मी. If it is maintaining a free frame list, when the new process comes, the operating system checks if that process needs 3 page frames. Will I be able to load it? No, it has to wait. If the new process comes, if that process requires 1 frame, then definitely your OS will load it. Have you understood how the paging technique works? So let us now read this. When you talk about simple paging, main memory is divided into equal fixed chunks that is called as pages. The process pages can be assigned to the available chunks in the main memory. So that is called as frames or page frames. Process does not need to occupy contiguous portion of memory. जो block available रहेगा, वही block वो आपको allocate करके देगा. What is paging? It divides your physical memory into fixed size blocks called as frames. It divides the memory into blocks of same size called as pages. Means I can say that inside your main memory, your division is in the form of frames. And your page table is having some entries which is having one index and the page number. At this point, Logically, if you write, this 0 can be considered as an offset, and this is the actual index. So this is called as mapping of physical and logical addressing through the intermediate thing, which is nothing but page table. So to set up the page table, to translate the logical and physical addressing, operating system keeps track of all the free frames. Accordingly, the process will be loaded into the main memory. So this is how the process is loaded. Based on the loading of processes, page table is maintained. Page table consists of entry, something called as index, and something called as physical number, where actually that page is available. Along with that, a free frame list is available so that your OS can understand who is the free page which is available. Have you understood up to this point, everyone? All right. Now, as I said, I'll take the same diagram. Assume. As I said, assume D5, D को एक और memory location लग रहा है D5. But what my D5 is saying, D5 is saying I do not require complete frame. Maybe I may require a half frame that is up to this much. And that's the reason D5 is saying I will be using only up to this point. And at this location, I have a problem. What is that problem is called? This free block is available in the main memory, and that free block cannot be basically used. This was the problem of internal fragmentation. Now, when I talk about internal fragmentation, this problem is available in the paging. So, अगर किसी ने पूछा, your operating system uses which technique to avoid external fragmentation? Answer is paging. But if I'm saying I want to remove internal fragmentation too, so for that we have segmentation. Have you understood the need of segmentation? Right? So, in a case of paging, main memory is divided into equal number of blocks. याद है क्या उस दिन मैंने आपको fixed size partition बताया था, where the memory is divided into equal number of blocks. And do you remember there is called as variable size partitioning? When you talk about variable size partitioning, in that case, do you remember there is something called as base and limit register? So, a fixed size partition means paging, and a variable size partitioning means that can be used in the segmentation. इससे क्या होगा? Internal fragmentation नहीं होगा. कैसे नहीं होगा? Let us observe. So segment is basically dividing the blocks into non-equal size, which is called as segment. So what is segment? It is a region of logically contiguous memory. Since I'm saying segmentation is basically a dynamic memory allocation, so it uses base and bound pairs. When the process gets loaded into the main memory, its different segments can be located anywhere. I will explain how the segmentation works. But in case of segmentation, there is no internal fragmentation. There is external fragmentation, but we can do or we can avoid external fragmentation using compaction, right? So let us understand this now, this diagram. Suppose what is segment? Segmentation is variable partitioning. Suppose in my program or in my system, I have to execute 5 processes. Segment 0 is subroutine. Segment 1 is basically working on some functionality. Segment 2 is having main program. Segment 3 is working on some stack related applications. Segment 4 is working on symbol table. So Logically related data is kept in one segment. That is first point. Segment 0 is requiring, let us say, total size as 1000. That is the limit. So segment 0 is starting at assume 1400. 1400 plus 1000 is 2400. That is nothing but limit. जैसे पेज टेबल में पेज नंबर एंड इंडेक्स रहता है, वैसे सेगमेंट टेबल में इट हैज टू एंट्रीज, one is limit, another is base. Second, segment number 2 requires only 400 size of data. So assume it is starting at 4300 and it is, just a second. Yeah, it's a genuine request. If you wish to call to any faculty, if that faculty disconnects your phone, it means maybe we are in another lecture. There was one number which was calling me since 15 minutes and 6 to 7 times, and it was a student only. So if normally the students gives us the call, and if we are in another lecture, we just give a message, we will give you a call back later, right? So not to worry, अगर किसी स्टूडेंट का मिस्ड कॉल हो भी जाता है तो हम वापस कॉल बैक करते हैं, ठीक? So do not get panic if some faculty do not receive your call at some point of time instead of calling 10 times. All right, coming back to the point, let us say I have a segment 3. Segment 2 was having, let us say, 400 limit. So if it is 4300 plus 400, it is 4700. It is ending at that location. Coming to segment 3, it requires, let us say, one more time 1100 of memory location. Segment 3 ka initial address is 3200 plus 1100, 4300, and so on. So how this memory is allocated? This is done by your operating system. This memory is calculated by operating system, how much it requires accordingly. जहां पे वो आपको memory allocate करके देगा, plus उसको कितना size चाहिए, that comes as a segment 0, segment 1, segment 2, segment 3, and segment 4. So this is called as segment table. So in conclusion, I can say that in case of segment, we do dynamic memory allocation. That means it is not fixed. Memory blocks are of variable in size. But to maintain that record, we need limit and the base register. So segment 0 is having the starting address as 1400 and the size that it requires is 1000. That is called as segment table. The question that was asked is, in case of segment table, the actual segments are loaded in which area? Obviously in the physical memory. Because normally students get confused कि physical memory क्या है? Physical memory is your RAM memory. So जब भी आपके memory में your OS uses combination of paging and segmentation. It is not only paging, it is not only segmentation. It uses both the techniques to allocate or to utilize your main memory as max as possible. So what is segmentation? Segmentation is basically visible to the programmer. They are provided as convenience to the logically related programs. मतलब segment paging में कैसे? जो process आया, directly it will be loaded onto the frames. In case of segmentation, logically related data can be put into the segment 0 and every segment will be loaded into that respective area. That is called as segmentation. So questions which can be asked over here is, what are the two entries of paging? Your answer should be, inside the page table, it consists the frame number. Frame number means the actual main memory number corresponding to the page. That means page table index. From this, we can from this index, we can obtain the actual frame number. In case of segmentable, it consists of two things. One, starting physical address of that number and the length of that segment. So these two things you should remember in case of paging and in case of segmentation. समझ में आया यहाँ तक? Everyone, yes or no? Yes. ठीक. If yes, let us go ahead to the next topic, which is called as virtual memory. Ajinkya, I'm muting you. Right. So when you talk about virtual memory, as the name says virtual, it means it is not visible to the user, but it is basically a kind of impression that user is using a large memory. Now, for example, if I'm saying I have a RAM, a main memory, which is of 4 GB, assume, right? So as a user, मुझे पता है कि I am using my RAM, which is of 4 GB, correct? But suppose I have a process, right? That process is taking, let us say, 1 GB. I am executing few processes, which is taking my 1 GB of data, 1 GB of main memory. But what I'm assuming I am executing 1 GB of processes means I am utilizing 1 GB of my 4 GB RAM. This is what is my impression. But what actually your OS does, OS maintains a virtual memory. What is virtual? Virtual means it is like the user will understand that he or she is using a large amount of main memory for its program execution. But no, it is not like that. Internally, your operating system maintains the concept of virtual memory. So how it does, let us understand. It's a separation of user logical memory from the physical memory. What your operating system does, only the part of the program needs to be in the memory for the execution. It allows the logical address space, which is much larger than the physical address space. The reason is आपका hard disk is 500 GB, आपका main memory is only 4 GB. So that is called as basically the memory which is available in the physical area, which is very less, right? Rather than your other external memories. So they allow the address spaces to be shared by the several processes. They allows more efficient process creation. It allows me to run more programs concurrently. Virtual memory gives the programmer the impression that he or she is dealing with a huge main memory. The OS loads automatically and on-demand pages of the running processes. मतलब अगर मैं बोलती हूँ I have my Explorer in this is my PC and in my PC I have C drive, D drive, E drive, F drive. ये सारा का सारा जो डेटा है वो मेरे मेन मेमोरी में नहीं आ सकता है. That is a very huge space. My main memory is, let us say, of 4 GB, 16 GB and so on. In that case, what your operating system do? Operating system brings only that much part which is required, which is in running mode. And that is done by the help of virtual memory. So the required pages need to be loaded in the main memory whenever required. Virtual memory is implemented using demand paging or demand segmentation. Right? Yes, Akshay, I will explain how that virtual memory works. Let us understand. Suppose I have a major disk, correct? And I have a user program A, which is taking 10 pages. I have a user program B, which is having 6 pages. Main memory consists of number of fixed length of frames, that is pages, for each program to the execution. So let us say in my main memory, A0 is loaded over here. Maybe A1 is loaded over here. A2 is loaded over here. Can you see A3 and A4 main memory में load नहीं किया गया है. A5 is over here. A6 is not there. A7, A8 and A9 is there. Similarly, B0, B1, B2, B3 है. B4 नहीं है. B5 and B6 है. What does it mean? It means that for current execution of user program A, page number 4 and page number 5 or page number 4 and page number, let us say 6 are not in use. तो वो डिस्क से आपकी मेन मेमोरी में लेके ही नहीं आएगा. आपको लगेगा कि मेरा पूरा प्रोग्राम मेन मेमोरी में आ गया है, but it is not so. It is basically the current program which is in the running mode. जितना पार्ट मेरा रन हो रहा है उतना ही पार्ट मेरे मेन मेमोरी में आएगा. Right? So understand the scenario. Over here, I will explain this scenario. Let us consider this diagram. Rather than going to this diagram, I will explain with the help of numbers. Now suppose how actually your virtual memory works. Inside the disk, I have A, B, C, D, E, F, G, H. These are the processes. And assume this is the process which I need to execute. What your system will do, your system will create a logical memory space over here. And it will allocate page A, page B, page C, page D, E, F, G, H. Means for this process, I'll just take this, right? Means for this process, okay, for this particular process, I will require 7 pages. This is the first thing. Second, out of which can you observe only page A is loaded over here, page C is loaded over here, and page F is loaded at this location. That means this is called as virtual memory concept. This is a physical memory which is called as your disk. Inside the disk, it has a different number of pages. Inside your logical memory, the pages are to be maintained from 0 to 7. What exactly this is? This is nothing but physical memory. Whenever I'm talking about pages, it maintains a page table. Now, look at this very carefully. This page table index number remains fixed. 0, 1, 2, 3 up to 7. This page table numbers will remain same. Right? At this point, can you please tell me, this is nothing but physical memory, means the main memory. Physical memory में इसको हम बोलते हैं frame number. Yes or no? Everyone, the actual frame number. Correct? Now, when I am executing this complete process, currently what is my requirement? Currently, I want only page A, let us say page C and page F to be loaded because I want to do execution part of this much only. Virtually, your operating system, what we will feel that our complete process is into the main memory. Answer is no. It maintains something called as logical space memory. And this logical space memory is nothing but your virtual memory, which is not visualized to you. Now, your operating system will only load page A page C, page F, wherever I have the space into the main memory. Now, can you please observe over here, page A is loaded into frame number 4. So it will maintain that entry into the page table. Page C is loaded into page 6. Page F is loaded into page 9. Why it is keeping all these blank? It is because it maintains that frame number exactly same. 0th location पे I have A, second location पे I have C, and 5th location पे I have F. Are you able to link? Are you able to link this? This is page A loaded at frame number 4. This is page C, which is loaded at page 6. This is page F, which is loaded at page 9. यहाँ तक समझ में आया? Everyone, have you understood up to this point? So instead of loading the complete process into the main memory from A to F, only 3 pages have been loaded into the main memory, right? And accordingly, it will maintain that frame number inside the page table. यहाँ तक समझ में आया? Everyone, have you understood up to this point? Right? Now, in this case, also please observe, a page table maintains one more column data, which is called as valid and invalid bit. What is that valid and invalid bit? Valid and invalid bit means if the V indicates, I'll change the color, V indicates page is available. V indicates valid. Page is available in available in main memory. And what does I indicates? Page is not there in main memory. Not there in the main memory means currently मेरा वो पेज एग्जीक्यूट नहीं हो रहा है. Currently सिर्फ ये V 4 6 9 ACF यही पेजेस मेरे मेन मेमोरी में लोडेड है and those are valid bit. Rest all are invalid bits. Did you get it? यहाँ तक समझ में आया? Everyone, what is valid and invalid? Now let us understand. When you talk about valid and invalid bit, in this case, now assume user or assume I wish to execute now B. मुझे अब B process execute करना है या B part. Is it available in the page table? What is the valid invalid bit entry? It is I. What does I indicate? It is invalid. What is invalid? It means that the page which I wish to execute, which is having invalid entry. If it is having invalid entry, then what? In that case, now B page will be loaded over here. Assume. कहाँ पे? I'm loading my B page at page 1. So I will make the entry as 1 and I will replace this I bit with V bit. It means that if the next page is demanded by the operating system, I wish to execute process B. It will first check page table entry. If the page table entry is invalid, it means page is not available in the main memory. I have to bring that page B from the logical memory to the physical memory. Assume my operating system have given page B as frame number 1. So it will first put that entry into that page table, make that I bit as a V bit. अब क्या हो गया? Instead of 7 pages, 4 pages are available in the physical memory. This whole process is called as demand paging. जैसे पेज का डिमांड आया, my OS have implemented demand paging. So that's why we say virtual memory is implemented using demand paging concept. Have you understood? Demand paging. Everyone. So I'll give you a quick review. This is my original process from A to G, A to H. Logically, मुझे लगेगा जब मैंने इस process को execution के लिए बोला है, logically it will be allocated 0 to 7 page numbers A to H. But when I say I'm using virtual memory, only the pages which I require at the initial, let us say A, C, and F, will be loaded into the main memory by keeping the correct entry into the page table, that is 4, 6, and 9. Once that entry is made into the page table, operating system will also maintain one more column called as valid and invalid. What does V indicates? V indicates the page is available in the main memory and I can perform its execution. If it is I, it means these pages are not loaded into the main memory. Also, if suppose next process B or inside the process B, inside this process, B page have been demanded. If B page have been demanded, it checks inside your page table. Initial entry was I indicates invalid, means the page is not available into this. If the while demanding, I'll write while demanding, if a page is not available inside the memory, then it is called as page fault. It is called as page fault. If there is a page fault, then that requested page is brought into the main memory at some free location, then that entry is made into the page table and it is V, that is called as virtual. Then that is V is indicating valid bit. What is valid? Means अब मेरा page B भी main memory में load हो गया. This whole process is called as virtual memory concept, which is implemented using demand paging. समझ में आया? Everyone. So this is what is a major diagram which I was trying to explain. There is a disk, there is a physical memory. Memory map means आपका page table and this is a virtual memory. So logical spacing is your virtual memory. So what is demand paging? Process of loading the page into the memory on demand is called as demand paging. जैसे B page का demand आया, तो मैंने पूरा process follow किया to load the P page from your logical space to the main memory, and that concept is called as demand paging. But when you talk about demand paging, it refers to the page, whether it is invalid or whether it is valid. Invalid means page is not there in the main memory. Valid means it is available into the main memory. Once it is available, then accordingly it will be loaded in. Otherwise, if it is not loaded, it means it is I bit. समझ में आया यहाँ तक? Everyone? Yes or no? Yes. Up to this point, any questions? ठीक, सबको समझ में आया? If yes, then now let us consider the other scenario. Other scenario means what? Suppose now I am saying I wish to load page E. Do I have page E in my page table as an entry as V or I? Page E, frame number 4, frame number 4 पे entry क्या है? I है. Is it I indicates it is not available in the main memory. If it is not available, that means I have to load it. But the thing is, my main memory is saying I am full. I do not have any space. I do not have any space in my main memory to load E page into this memory area. So what is the solution? The solution is, it is a page fault. Page fault है मतलब मेरा यहाँ पे page available नहीं है and I'm not able to execute it. So in that case, we have to take out some process or take out some page. Assume if I'm saying I am selecting C and I'm saying I will take out the C process out from the main memory. I will take it out. I will swap out. जिस process को हम बोलते हैं swap out C. I'm taking randomly. Swap out C से क्या होगा? Swap out C से मेरा 6th वाला ब्लॉक फ्री हो जाएगा. क्या मैं उस लोकेशन पे E को लोड कर सकती हूँ? Yes. Have you understood up to this point? It means while using the demand paging, if your physical memory is full, at that moment, there will be some page which will be swapped out from the main memory. And that page, जिसको हमने swap out किया है, that page is called as victim page. उसको हम क्या बोलेंगे? Victim, because उसको हमने target किया that you have to go out from the swap from the main memory because I have to load page E. That is called as victim page. So in a case of virtual memory, if I have basically some page which I cannot load into the main memory, I have to select some page which I have to bring it out. I have to swap it out. That page is called as victim page. समझ में आया क्या है victim page? Everyone? Yes. Now, when I say victim, again, whether I have to go for A, whether I have to go for C, or whether I have to go for F. For that, we have something called as page replacement algorithm. It is because we need to find out some page in the memory which is not really in use. I have to swap it out. So swapping out the page, selection of that page is based on page replacement policy. So there are 3 categories. जो भी पेज को मैं बाहर करूंगी, that page is called as victim page, and swap in the desired page. Obviously, the page which I have as a victim, उसका बाद में page table में entry obviously change होगा, valid का invalid, invalid का valid, and so on, right? So, in case of page replacement, first, if there is a free frame, use it. If there is no free frame, page replacement algorithm will be helping us to select the victim page. So there are 3 page replacement policies. First in, first out. Second, least recently used. Third, optimal. अब समझ में आया पेज रिप्लेसमेंट पॉलिसी क्यों यूज करते हैं? It is because I want to replace some page which is victim page from my main memory such that I am able to load a new page. Now, which page is to be taken out? That decision is done by your page replacement algorithms, and that is nothing but 3 algorithms are there. One is FIFO, second is LRU, third is optimal. Is it clear up to this point? So that I will go ahead to the page replacement algorithms. Any queries so far? I'll wait for a minute. No queries? Let us proceed then. Let us talk about FIFO, that is first in, first out. Suppose, assume this is the example, first in, first out. Suppose, I'll say this is my frame size. जैसे मेरा यहाँ पे मेन मेमोरी में फ्रेम साइज कितना था 15, right? Here I'll say my frame size is 3. What is the frame size? It is equal to 3. We are working with FIFO policy. जो first आया वो first out होगा. First in, first out policy. So let us assume initially I have 3 free frames. I'll draw one diagram, or I'll draw initial memory mapping like this, which is having 3 frames into it. This is the first frame, this is second, this is the third. I'm considering 3 size. First page which have been arrived is 7. Do I have a memory space? Yes, C7 will be taken in. Next, 0 will be taken in because I have the space. 1 will be taken in. Have you understood up to this point? Right. Next May, 2 came. Do I have a available free space? No, I do not have the available free space. अब चांस आता है किसी को victim बनाने का, 7 or 0 or 1. Which policy I'm using? FIFO policy. The page which came first will go out first. Which page came first out of 701? 7 came first. 7 will be replaced with 2. So 2 is loaded. Have you understood? Next. Also, can I say over here, 7 is replaced means it is a page fault. PF लिखती हूँ मैं. Can I say it's a page fault? Because 2 was there, 2 मैंने replace किया, तो page fault हुआ. Because page was not available into the main memory, I had to do demand paging and I have to bring that. That's a page fault. Next page came as 0. Do I have 0? Yes, it is already present. Is it a page fault? Is it a page fault? No. Next. पेज फुल है लेकिन पेज फॉल्ट हो रहा है ना यहाँ पे. पेज फॉल्ट मतलब क्या? अगर मेरा पेज अवेलेबल नहीं है, मुझे डिमांड पेजिंग से पेज लेके आना है, उसको हम पेज फॉल्ट बोलते हैं. 0, it's already there. Now 3, I have to load 3, but the question is, I do not have 3 in my main memory. So which page I have to go for? कौन सा पेज बाद में आया था? 07 के बाद आया. So I have to basically replace the 0 with a 3. Next page came as 0. So again, here, this will be replaced with 0 because it came last. Next page came as 4. 4 will be loaded. Where? At this location. Next page 2 came. 2 page will be loaded. With whom? With 3 because 3 uske baad mein aaya. Next page 3, it will be loaded but replaced with a 0 because 0 came last. It goes in a circular fashion, one by one. 0 aaya, again there is the replacement. 3, it's already there. 2, it's already there. 1, let it get loaded. With whom? obviously 2 because 2 सबसे बाद में पहले आया था. Now 0, 1, 3, again 2 will be loaded. So here this will be replaced with a 3 because जो पहले आया वो पहले बाहर जाएगा. This is how it is. 0, it's already there. 1, it's already there. Again 7, it will be replaced with 0. Again 0, it will be replaced with 1. Again 1, it will be replaced with 2. So if you talk about the number of times I am replacing the page, उतने number of times हमारा page fault होता है. So this is page fault. This is also here page fault. Here also there was a page fault. Here also there was a page fault. Here also there was a page fault. Here there was no page fault. Here there was a page fault. Again there was a page fault. Again there was a page fault. Again there was a page fault. Count the number of page faults. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So there are total 11 page faults. समझ में आया? This is called as FIFO, first in, first out policy. Any questions so far? Have you understood, everyone? Any questions so far? Good. So this was about FIFO page replacement policy. The second says least recently used. Let us take the diagram of least recently used. I'll consider this same reference string. Okay. LRU stands for least recently used. Let us work with this. LRU least recently used means it checks the past reference. जो सबसे पहले number of times you can say it will see the past reference. We will go ahead step by step. First, 7 loaded into the main memory, 0 loaded into the main memory, 1 loaded into the main memory. Now 2 comes. जैसे ही 2 आता है, it will observe which it will go into the past. Look at the back. If I move towards the past references, which is the page which is least recently used? जो recent कम use हुआ है 7. So this will replace with 7. So 7 will be replaced and 2 will be loaded. Next, 0 is already present. अब next कौन सा आया? Next page that have arrived as 3. Observe. Currently my scenario is 201. If I look into the past, so 2 is here, 0 is here, 1 is least recently used. So 1 के साथ 3 will get replaced. Did you understand? In the past, whatever is the current scenario of my page frame, in the past, the one which have been least recently used will be given the chance or will be the victim page. Let us observe. 0 is there. Now it's the chance to load the 4. But 4 load करने के पहले it will observe what are the current pages. 203. 0 यहाँ पे ही है, 3 यहाँ पे ही है, but 2 यहाँ पे है. So replace this 2 with 4. Have you understood? Everyone. One more time. 2 have come. What is the current scenario? 4 is here, 0 is here, 3 is here. 3 is least recently used. 3 को replace किया 2 के साथ. Next page, 3 have come. What is the current scenario? 4 is here, 0 is here, 2 is here. Who is the least recently used in past? 0. So replace the 0 with 3. Again, 0 I have to load. What is the current scenario? 4, 3, 2. 4 is here, 3 is here, 2 is here. Which is the least recently used? 4 is the least recently used. That is 0. 3 already present, 2 already present. Let us go for 1 and check for 1. What was the last status of the frame? 0, 3, 2. 0 is here, 3 is here, 2 is here. Which is the least recently used? 0. Replace the 0 with 1. 2 already there. Again for 0, 1, 3, 2. 1 is here, 3 is here, 2 is here. Obviously, this will replace with 0. 1 is already there, right? Comes as 7. So, current status was 102. 1 यहाँ पे है, 0 यहाँ पे है, 2 is here. Least recently used is 2. Replace 2 with 7. 0 already there, 1 already there. Let us try to count number of page faults. Here I'll say first page fault, second page fault, then the third page fault, then this is the fourth page fault, here fifth page fault, sixth page fault, seventh page fault, then this is 8, this is 9, and the last one is 10. So there are total 10 page faults in this scenario. समझ में आया? LRU? Everyone. It's easy. Just see the last reference, right? Let us take optimal scenario. Sometimes in these, Monali, in this theoretical questions can be asked, like, in which type of page replacement policy the past reference of the page has been checked? Your answer should be LRU. In which case of the CPU, this page replacement policy, the first came page will be taken it out, then that is FIFO policy. So theoretical concept आपको समझाने के लिए I am taking 1 or 2 examples. Okay. All right. Let us go ahead. Optimal, which is practically not possible for implementation because it sees future references. It is theoretical concept. Because मुझे ये नहीं पता है कि फ्यूचर में यूजर क्या डिमांड करेगा नेक्स्ट पेज का. So let us understand the scenario theoretically. Future reference string 7 loaded, 0 loaded, 1 loaded. Now comes the point of 2. I have to load 2, but out of 7, 0, 1, सबसे दूर कौन है? 0 तो नेक्स्ट ही यूज होने वाला है, 1 तो इधर फिर से यूज होने वाला है, 7 सबसे दूर है, so I will replace 7 with 2. The page which may be used more far in your future reference string, that will be replaced. Next, observe. 0, it's already there. 3, I have to load. What was the scenario? 0 is here, 1 is here, and 2 is here. सबसे दूर कौन है? 1. So I will replace this 1 with 3. Next, 0, it's already there. 4, I need to load 4. Which are the current frames? 204. 2 तो next में ही आने वाला है, 0 इधर आने वाला है, 4 कहीं पे भी नहीं आने वाला है. Just replace. 203, 3 is here. So 2 is here, 0 is here, 3 is here. So it will replace this. So 2, 3 and 0, because 0 will be used at the later stage. 2 is already there, 3 is already there, 0 I have to replace. So if I have to replace, observe the current status. It is having 2, 4 and 3. I wish to load 0. 2 is here, 3 is here. 4 is never not there in the future. Replace it. 3 already there, 2 already there. I have to load 1. What is the previous status? It is 2, then 0, then 3 is never been used. 3 will be replaced with 1. 2 is there, 0 is there, 1 is there. Comes at 7. 7 I have to replace, but with whom? 2, 0, 1. 0 यहाँ पे use होने वाला है, 1 यहाँ पे use होने वाला है. Replace it with 2. That is this. So let us count the page faults. This was the first page fault. This is the second page fault. This is the third page fault. Next page fault. This is also a page fault. This is a page fault. And finally, there is no page fault over here. So 1, 2, 3, 4, 5, 6, 6 page faults. So the page which is not being used in the future reference string can be replaced in case of optimal. समझ में आया एवरीवन? सो अगर मैं आपको थियरी वाइज बताती थी तो आपको थोड़ा सा डिफिकल्ट होता था, सो आई हैव टेकन एग्जांपल ऑफ इट. डिड यू अंडरस्टैंड पेज रिप्लेसमेंट पॉलिसीज? गुड. Let us go ahead. So we have seen memory part completely, memory management techniques, page replacement policies, what is paging, what is segmentation, what is physical addressing, what is logical addressing, and finally we will say that we have seen the page replacement policy. Saurabh, if we talk about which one is the best, obviously LRU will be the best, because optimal cannot be implemented directly. आपको ये नहीं पता है कि फ्यूचर में मेरा यूजर मुझसे कौन सा पेज का you can say डिमांड कर सकता है. So normally if any page replacement policy is having less number of page faults, in that case that is the best policy. So in our case, your FIFO and LRU may say LRU was having the less number of page faults, so I can say that was the best one. Okay, everyone. In some of the question, in some of the books, what they have done, जो 6 page faults अभी यहाँ पे मेरे आए, right? But in some of the books, they have maintained these जो पहले वाले 3 frames है, this is the first frame, this is the second frame, this is the third frame, plus 3 faults भी किए हैं. मतलब अगर पेज अवेलेबल नहीं है तो भी वो लोगों ने कंसिडर किया है इट्स अ पेज फॉल्ट. सो 6 या फिर 9 ऐसे दोनों भी आंसर्स करेक्ट हो सकते हैं. ओके, हैव यू अंडरस्टूड अप टू दिस पॉइंट, सो दैट वी विल गो अहेड. All right. So let us come to the next point, which is called as file. So when we talk about file, it is a collection of logically related data or the information. It is a file of stream or bytes or bits and bytes. You can take any files, maybe text files, document files, image files, video files, anyway, anything. Why do we have files? Because we have to keep some basic storage unit for the file. Every file maintains something called as data as well as metadata. What is metadata? It is nothing but the detailed information about that file. What is detailed information? Maybe the name of the file, size of the file, date of creation, time of creation, type of the file, its header information, and its size information, the location. That is called as data. So normally we can say metadata is nothing but data about data or in detail information about the file. And what is data? It is nothing but actual file contents. There can be different number of file attributes like the name of the file, type, location, size, etc. We can perform different file operations, maybe create, maybe delete, maybe write, read, and so on. Now, if you talk about file system, right, if you're using Windows operating system, it has its own file system. If you're using Ubuntu, in that case, it has a UFS file system. If you're using maybe Apple or Mac, in that case, they have HFS file system. So every system is having its own type of manner the way the files are stored. So how your files should get stored and organized in your system that is maintained by your file system. Every operating system have their own specific names for their file systems to be maintained. So what is file system? It's a way to store the data onto the disk in an organized manner so that it can access efficiently. In your Windows, you make some drives, right? And वो drives में data कैसे store होता है? For that, we have something called as file system. Now, whenever you talk about process, right? आपको याद है क्या हमने किया था? Every process, whenever it is created, one block is generated, and that block is called as, whenever any PCB. Very good. PCB stands for process control block. याद है सबको? याद है क्या? मैंने बताया था ना? Yes. So, can anyone tell me what is the another name for PCB? Once it was asked in exams. Any other name given to the PCB? Process descriptor. याद है? The program process control block is also called as process descriptor. ये कब create होता है? Whenever I create any process, at that moment PCB of that PCB of that process gets created. Similarly, when you talk about file, right? At that moment, there is something called as FCB, file control block, which is also called as inode, called as index node. So when a process is created, its PCB is created. And when file is created, FCB is created. So an inode or the index node is a control structure that contains the key information needed by operating system to access the particular file. So on the disk, there is an inode table that contains the inode of all the files in the system. When the file is opened, its inode is brought into the main memory and stored into the memory resident inode table. Now, suppose I have, let us say, this table. This is called as one file table. Assume, right? Assume I have file1.txt. Maybe I have demo.c file. Maybe I have C, let us say day4_1.cpp. Maybe I have something book.jpg, right? JPG. Maybe I have file2.docs and so on. There can be different types of files in my machine. Every file is having its own extension and its information is maintained as a metadata. Every file is having its starting address. Maybe I'm saying this is at 1000. This is stored at, let us say, memory location 2000. This may be stored at 3000. Memory, maybe this is at 5000. Maybe at is 5400. Assume. So this table is called as inode table. Okay. So suppose in my machine, I am requesting file1.txt. Your operating system will check, do I have an entry for file1.txt? Yes. Do I have information about it to fetch this from the main memory, from the disk? Yes. Then it will go to the disk. It will take your file from the disk and then it will load it into the main memory. right? So what I want to conclude over here is, can I say, जब आप मशीन स्टार्ट करते हो at that moment पूरा का पूरा डिस्क स्ट्रक्चर आपको क्यों दिखता है? Because of this inode table. Your system initially maintains all the inode tables and ready such that whenever the user opens that file, it first checks the entry into this inode table. If that file is available, then it goes to that respective location and load it into your main memory. And that is called as inode is brought into the memory whenever the file is opened, and it contains the complete information about the addresses only, right? जैसे ही उसको address मिल गया, then information about that file can be kept in one structure called as file control block, which will have name of the file, type of the file, size, parent folder, access permissions, group members, etc. and so on. So due to your inode, your files are visible to you, and due to your inode table, when I click that file, that gets opened. समझ में आया? Everyone? Yes. Now, any questions? Are you there? Right. So let us observe some allocation techniques on the disk. Means when we talk about this disk, right? This disk is having different allocation techniques. How the file can be stored. One is contiguous, another is linked, another is blocked. Let us observe. For example, in this scenario, if your file, assume, I'll take it over here. I'll say I have the first file as count. Okay. This count file, my operating system have given me disk sector number 0. So count is starting at 0th location. It is saying I needed 2 blocks. So block 1 and block 2 is allocated in a continuous way. Suppose I have one other file tr. The initial address is given as 14 and it says I need 3 blocks. So tr will be loaded at this, and first block, second block and third block will be allocated. Suppose next file is mail, which is having starting address as 19 and it takes 6 memory blocks. So mail will be starting at 19, 1, 2, 3, 4, 5, 6 blocks are allocated. Suppose next allocation is coming for list file, which need 28 and which need 4 len, and starting block मुझे 28 मिला. So it will start from 28, 1, 2, 3 and 4. And finally, I have, let us say, file number F, which is starting at, let us say, 6th number block, which need 2 memory blocks. So this F will be loaded over here, which is using 2 blocks. This is called as contiguous memory allocation. The files which receives the start location, they tell the len, accordingly continuous memory blocks are allocated. This category is called as contiguous disk allocation. But in case of contiguous disk allocation, can I say yahan pe block number 2, block number 3, block number 4 and 5, again in between 8, 9, 10, 11, 12 and 13, 17 and 18 and 25, 26, 27, all these are unused blocks within main memory. So can you please tell me which problem is this? Which problem is this? Is it nothing but external fragmentation? Yes. So in case of contiguous memory allocation, if I'm saying अब मेरे पास ऐसा एक फाइल आया है जिसको 5 ब्लॉक्स चाहिए, तो 2 3 4 5 में मैं अलोकेट ही नहीं कर सकती हूँ, बिकॉज कंटीजियस मीन्स कंटिन्यूस में मिलना चाहिए. That is called as external fragmentation. So contiguous memory allocation faces which problem? External fragmentation problem. Contiguous memory allocation के लिए your operating system maintains a directory structure having 3 fields. One is the file name, second is the start location, third is the length of the image. Did you get it? What do you mean by contiguous memory allocation? डिस्क अलोकेशन की बात कर रहे हैं हम. एवरीवन समझ में आया? यस. नेक्स्ट इज लिंक्ड अलोकेशन. लेट अस अंडरस्टैंड लिंक्ड अलोकेशन. इन केस ऑफ लिंक्ड अलोकेशन, द फाइल इज बेसिकली not in contiguous way, it is linked. Let us understand. First of all, in this case, a directory structure consists of the file name and starting address and the last address. Let us say, if I have this diagram, in my file, first memory block is 9. So it will first go to 9th block. Please observe, this is the 9th block. Next, it will go to 16. It will go to 16. Next, it will go to 1. Next, it will go to 10. Next, it will go to 25, which is -1. So what I want to say over here is, in a case of linked allocation, can I say at the end of 9th block, address of next block is stored? Obviously, yes. Again, 9th say I am moving to 16th block. 16th block के last में next address क्या रहेगा block का? That is block number 1. Again, block 1 से उसको 10th का address रहेगा, 10th से 25th. And I can say every block will have one entry for storing next address block, next block address. Can I conclude like this? Right. Will I require a pointer for this to hold the address? Yes, if I require a pointer, so here due to this I will require more memory, kind of linked list. Also, the last block indicates -1, which is end of block. The advantages over here is, यहाँ पे मेरा external fragmentation नहीं होगा. But the major disadvantage is, if one block got corrupted or got destroyed, the whole file cannot be opened. Obviously, yes. कभी कभी आपने देखा है क्या, कभी आप वर्ड डॉक्यूमेंट पे काम करते हो और वो बीच में यू कैन से करप्ट हो जाती है, राइट? इन दैट केस एंड आफ्टर दैट इफ यू ट्राई टू ओपन दैट वर्ड फाइल, तो वो आपको एरर देता है, फाइल कैन नॉट बी ओपन्ड. हैव यू एवर सीन दिस? Yes or no? It is because उस फाइल को लिंक नहीं मिल रहा है कि मेरा स्टार्ट ब्लॉक कहाँ पे है और एंड ब्लॉक कहाँ पे है. So if one block gets destroyed, then the whole file cannot be opened. It can get corrupted. This is a disadvantage of linked allocation. So this is linked allocation. What about indexed allocation or block allocation? Let us understand. In a case of indexed allocation, your operating system maintains one block and that block is called as index block. जैसे आपके बुक में इंडेक्स रहती है. So here your operating system is saying this block number 19 is my index block, जहां पे मेरे फाइल का पूरा इंफॉर्मेशन है. 19 say 9 is the first block. This is my 0th block, first block, second, third, and fourth. That means in case of indexed allocation, it will maintain the index format. What is that index format? The 0th block is 99th block. The first block is 16th block. Second block is first block. Third is 10th block. Fourth is 25th block. It will maintain the index of all the pages. These are called as page numbers of all the pages occupied by your file. So I will say here the name of the file is Jeep. Its whole information is stored into the block number 19. So your operating system will go to the 19th block, and can you see here 5 blocks are used. कैसे पता चला 5 blocks? 9, 16, 1, 10 and 25. Rest are -1, -1, -1 means unused. हर एक इंडेक्स ब्लॉक की कुछ साइज फिक्स रहती है. Assume I'm saying this is my index block whose size is fixed, maybe 8 blocks, out of which 5 I am using for this particular file called as Jeep, and 3 are unused. जैसे ही फाइल साइज बढ़ जाएगी तो वो मुझे ब्लॉक अलोकेट करके देगा. But the disadvantage of index block is one complete block is dedicated for indexed allocation. So this will waste more memory. Have you understood what is index allocation? डायरेक्टरी स्ट्रक्चर के ऊपर क्वेश्चन आता है. अगर मैं कंटीजियस अलोकेशन की बात करती हूँ, डायरेक्टरी स्ट्रक्चर कंसिस्ट ऑफ फाइल नेम, स्टार्ट एंड लेंथ. अगर मैं लिंक्ड अलोकेशन की बात करती हूँ, डायरेक्टरी स्ट्रक्चर कंसिस्ट ऑफ फाइल नेम, स्टार्ट ब्लॉक एंड द एंड ब्लॉक. इंडेक्स अलोकेशन की बात करती हूँ तो डायरेक्टरी स्ट्रक्चर कंसिस्ट ऑफ फाइल नेम एंड द इंडेक्स ब्लॉक. हैव यू अंडरस्टूड एवरीवन? Any questions so far? Everyone, did you get it up to this point? Are you guys awake and are you there? Or am I audible? Yes, good. ठीक है. Let us take the last topic, which is called as disk scheduling. So what is disk scheduling? Disk scheduling is done by operating system to schedule IO requests arriving from the disk, right? Disk scheduling is important because when we are talking about disk scheduling, then multiple IO requests may arrive by the different processes. Let us understand the disk structure first. For example, if I'm talking about this is the disk, assume the disk is divided in the form of concentric circles, right? Now, in the disk, consider this is basically in a circular fashion. In the disk, these disks are having different number of tracks. And these tracks are divided into number of sectors. So I will say here, these are the tracks. Right? And I'll say this one, you can say, ये एक complete sector हो गया. This one complete is called as a sector. This green color, it is a sector. The complete one is called as a sector, right? Now, when you talk about a track, so these are all tracks, and this complete, the green one, which I'm talking about, is a sector. Now, in case of disk, there is something which is called as a read-write head. So I can say this is called as read or write head, which is controlled by some controller. Whenever a user requests, suppose a user is saying, I wish to go for reading the data into, let us say, sector number this and track number this. At that moment, this read write head is brought into this location, and this is called as disk. The read or write operation is to be performed. Now, if you talk practically, अगर मैं यहाँ पे, if we say, if I would have been onto, let us say, this track, assume यहाँ पे रहती थी, right? तो can I say मैं fastly मेरा read write head बाजू में ही आ जाता था? Can I say like this? The time required from this to this is very less. Okay. But if I would have been assumed at this track, then obviously the time required for my read write head is basically more compared to this. That is but obvious. All right. So that is basically for accessing the data from the disk using this read write head is having certain criteria, right? And those criteria, this is called as disk structure normally. I'll save this for your reference. So disk structure is basically, we have seen every disk is having some criteria. One is seek time, another is rotational latency, there is transfer time, disk access time, and disk response time. The seek time is the time which is taken to locate the disk arm to specify track whenever the data is to be read and write. मतलब मुझे कितना time लगा, my disk read write head or disk arm should reach to that particular track. That is called as seek time. What is rotational latency? When I say disk, the disk always rotate in a circular fashion. If I'm saying, if I would have been over here, then obviously उसको rotate होके उस current data पे आने के लिए ज़्यादा time लगता था. So that is basically latency, or you can say delay. So the time taken by the desired sector of the disk to rotate into the position so that it can access the read write heads. So that is called as rotational latency. Seek time means मुझे कौन से सेक्टर और कौन से ट्रैक से डेटा रीड करना है, उसके लिए मेरे डिस्क को कितना टाइम लगता है, that is seek time. But if I reached at that sector and the track, to position that sector, to position that track, we need little more time, and that is called as rotational latency. पहले वो सर्च करता है in which track, in which sector I have to go, that is seek time. After searching, it rotates its read write head towards the correct sector, that is rotational latency. Transfer time means what? Suppose I'm saying I wish to write the data into this. Maybe it took 5 milliseconds. That is what is the transfer time. So the time taken to transfer the data, it is completely based on rotating speed of the disk and number of bytes to be transferred. अगर मेरे पास ज़्यादा data लिखना है, read write करना है, तो obviously it will take more time. So what is actually the disk access time? It is seek time plus rotational latency plus the transfer time. What is response time? It is a time spent by the request writing to perform its IO operation. It is basically the response, how much time it took for me to read the data and to write the data, that is disk response time. So this is basically a disk scheduling criteria. This helps when you talk about basically you are accessing the hard disk, you are accessing the external disk, you are accessing the secondary media storage. तो मेरा जो disk read write disk का read write head है, read write arm है, how much time it is taking for accessing that data. So for that, we have criteria. Now, अब क्वेश्चन ये आता है कि अगर मैं यहां सपोज आई एम सेइंग सीक्वेंस, आई एम सेइंग सम सीक्वेंस, I have to perform operations on following numbers, maybe track numbers or sector numbers. Maybe I'll say 20, maybe I'll say 1, maybe I'll say 30, maybe I'll say 15, maybe I'll say 16, maybe I'll say 80, then I'll say 86 and so on. So what are these numbers? These are, let us say, some sector numbers or sector numbers, let us assume, right? And as I say, disk is basically given in contiguous tracks. ऐसा ही होता है ना, पहला track 1 रहेगा, फिर track 2, track 3. Everyone, do you agree? ऐसा तो नहीं होगा track 10 बीच में आ जाएगा. No, the tracks are in ascending or descending order. Let us, I'm saying ascending order. Ascending order में ही रहेंगे, right? तो अगर मैं बोलती हूँ जो पहला ट्रैक आया मैं पहले वो रीड करूंगी, तो ऑब्वियसली फर्स्ट इट विल गो टू ट्रैक 20, then track 1, then 30, then 1, then 16, then 80, then 86. This is I have decided. Second, I'll say no, whoever is near to 20, I will cover up that. Maybe 20, 15, 16 I will cover, then I'll cover 1, then I'll go to 30, then 80 and 86, right? This can be the sequence. Or maybe I'll say I may go ahead with the, you can say any other algorithm. Maybe I'll start from end. Maybe up 86 say 80, 80 say 30, then 20, then 16, 15 and 1 and so on. So I cannot decide directly which type of criteria I should follow. So for that, you use disk scheduling algorithms. समझ में आया क्यों disk scheduling algorithms रहते हैं? So there are many categories. There is first come first serve, shortest seek time first, scan, C-scan, look and C-look. Let us observe first come first serve. Again, in this case, the theory questions can be asked. The track which came first will be given the chance first is which kind of this scheduling policy called as first come first serve. Assume I have got the queue as 98, 183, 37, 122, 14, this and this and this. And it is saying my current head is basically at location 53. I have the total 200 tracks. So I will first arrange 0 to 200, out of which 14 hai, okay, 37, okay, 53, yes, 65, 67. पहले जो भी आपको क्यू दिया गया है, arrange it in ascending order, write it like this. Did you all get the first step? Everyone, whatever number of tracks are given to you, arrange it in ascending order and write it like this, the way I have written. Have you understood up to this point? All right. Now, this is scanning methods. Now, let us say we are saying the current cursor. अब मैं operation मेरा disk 53 location पे है. Who is the first one which came? 98. From 53, it will go to 98. What is the difference between 98 and 53? What is the difference between 98 and 53? Is it 45? Yes or no? Yes. Next request, 183. From 98, it will go to 183. What is the difference between 98 and 183? It is 85. Correct? Next, it will come back 37. So it will come from 183 to 37. I'll get some number over here. Again 122. From 37, it will go to 122. Again, I'll get some difference. I'll go to 14 because I'm using first come, first serve. 14, it will go over here. The difference I'll find. Again, 124. I'll go to 124. The difference I'll find. 65, I'll go from here to here. The difference I will find. And it is always a positive difference. 67, I'll find it over here. It means that whatever came first will be served first. First come, first serve. ये सारे नंबर कैलकुलेशन आप करोगे तो आंसर आएगा आपको 640 cylinders. 640. So what exactly is 640? It is like 640 cylinders that it has to go ahead for reaching to each and every number of track or the sector. So this illustration shows the head movement, read-write head movement of 640 cylinders. This is first come, first serve. Considering the current head position is at 53. समझ में आया यहाँ तक? Everyone. Yes or no? Yes. Similarly, next is shortest seek time first. Initially, I am at 53, right? It will observe, मुझे 65 भी read करना है, मुझे 37 भी read करना है. But what is the difference between 65 and 53? Is it 12? Right. What is the difference between 53 and 37? Is it 16? Yes. Who is the minor one? Obviously 53 और 65 के बीच में difference कम है, so it will first go over here. Obviously nearer to 65 it is 67. It will go to 67 track. 67 के बाद I have 98 to go or I have 37 to go. The difference between 67 and 37 is 30, but difference between 98 and 67 is more, so it will first go to 37. From 37, it will again observe I have to traverse either at 98 or at 14. Obviously, the 14 is nearer to me. I will travel 14 and I will then go back to 98, then 122, 124 and 183. So this is called as shortest seek time first. It selects the request with a minimum seek time from the current head position. So the question that can be asked over here is, which kind of disk scheduling algorithm selects minimum seek time from the current head position for the request is to be served? So you have to select the option shortest seek time first. मतलब आपको क्वेश्चन जो है वो अच्छे से रीड करना है एंड अकॉर्डिंगली यू हैव टू सेलेक्ट दैट यू कैन से पॉलिसी. हैव यू अंडरस्टूड अप टू दिस पॉइंट? Similarly, if you find the difference between these, that is 53 minus 65, then 65 minus 67, 67 minus 37, in that case it will show you 236 cylinders. Starting position was 53 pawan. 53 से 65 nearer है, short है, उन दोनों के बीच में distance is short, so it will go to 65. Obviously 65 and 67 are nearer, so it will go into this direction and so on. Have you all understood shortest seek time first? All right, let us go ahead to the next point, scan. Now, when I say scan, the disk arm starts at one end of the disk and move towards the other end, servicing the request until it gets to the other end of the scan. जैसे आपका स्कैनर वर्क करता है, एक डायरेक्शन में स्कैनर पूरा कंप्लीट स्कैन करता है, goes up to end and then come back. Yes or no? Similarly, the scan read-write head works like a scan. Currently, I am at 53 location. Now is the job of operating system whether to start from left hand side or whether to go ahead with the right hand side. If I start from left hand side, so 53 say I'll serve 37, I'll serve 14, I'll go to 0. 0 से I'll go to 65, 67, 98, 122, 124, 183. Have you understood how the scan works? It starts the disk movement or read-write head movement towards the one direction by serving all the details which are available in between. And then it moves ahead to the other direction and starts serving the sectors. That is called as scan. समझ में आया? It's like, it is also called as elevator, जैसे आपका lift work करता है. In case of scan, please observe, this goes from here till the end and up to here, over here. The variation to the scan is a circular scan. In case of circular scan, it moves into the one direction like a scan only. 53, 65, 67, 98, 122, 124, 183. It goes up to the extreme end. Since it is circular, वो circular fashion में, it will come back to the 0th location and then it again gives the requests. So the head moves from one end of the disk to the other, servicing request as it goes on. यहाँ से to the next end, and by giving the services who are coming in between, without servicing any request on its return trip. Scan में क्या था? Return journey में भी it was servicing. C scan में it will not serve anyone into its return journey, and it will come back to this location and then it go, right? Rishi, how it decides its direction. Now there are different algorithms. These are the different algorithms that is used by your operating system. Memory management के algorithms, आपके disk scheduling के algorithm, process scheduling के algorithms. Your OS is smart enough to utilize the best possible algorithm for process management, for memory management, for disk management. So we cannot decide which direction it is using. This is just for your visualization how these algorithms works, but that job is obviously done by your operating system. You cannot say ki use C-scan algorithm or use scan algorithm. That's a decision made by your operating system. That is the basic functionality of operating system. Okay, Rishi? Have you understood C-scan and scan? Right, Rishi, that even though in your exam you can go from any direction, you will get the same answer. Means some books they are moving from left towards right. In some of the books it is mentioned from right to left. So even the most important thing is that अगर आप scan ले रहे हो तो take it into one direction, go ahead while servicing into the other direction. अगर आपने C scan भी लिया, in this scenario 53, 37, 14, 0 लिया और एक सर्क्यूलर स्कैन में सीधा आप 199 में जाके then return journey में you served 183, 124, 122, 90, 98 and so on. That is also absolutely okay. Both the options are correct. But in your exams, rarely it is asked कि आप अभी मुझे सिलेंडर का स्कैन कितना काउंट होता है वो बताओ. Normally the questions are asked in the way the theory is written, the definition part that makes us more important. Okay, so what is C look? C look is seen, but in this case, जैसे आपका स्कैनर वन एंड से एक्सट्रीम दूसरी एंड में जाता है, यहाँ पे भी, is it going from extreme one end to another end? Yes. But in case of look, it will look into the same direction only. 53, 65, 67, 98, 122, 124, up to 183. यहाँ पे मैं 199 पे नहीं जा रही हूँ. C scan में मैं 199 तक जा रही थी. That is the difference between scan and look. The disk arm only goes as far as the last request in the each direction, then reverses the direction immediately without going to the first head. क्या ये मेरा रिवर्स में 0 पे गया क्या? नहीं गया. जहां पे उसका फर्स्ट रिक्वेस्ट रहेगा वो वहां पे जाएगा. That is called as look and see look. लुक में वो रिवर्स में आके डायरेक्ट 37 एंड 14 पे जाएगा. सी लुक में इट विल कम बैक टू 14 एंड इट विल स्टॉप एट 37. दैट इज इन सर्क्यूलर लुक. So have you all understood? A one-line description of all these algorithms I've included onto this slide. First come, the requests are addressed in order they arrive into the disk queue. Shortest seek time, requests having shortest seek time are executed first. Scan algorithm में disk arm moves into the particular direction, services the request coming on its path and reaching at the end of the disk. But it works as a lift, and that is nothing but elevator algorithm. C-scan में it moves in the circular fashion, and it is also called as a C-scan. It is basically moves into the circular fashion. It is similar to scan, but in the reverse direction, it never serves, or in the return journey, it never serves the tracks. Look is the same as scan, provided look never goes to the extreme end. It will go up to only the last request. And C look is same as C scan, but here also it will not go to the extreme end of this. It will go up to the first or the last request, whoever it is. So these are disk scheduling algorithms. All right. So we have started with introduction to operating system. We have seen what do you mean by OS, definitions of OS, what is user mode, kernel mode, user spaces, kernel spaces. Then we have started with a concept called as memory management, then process management. First, we have seen process management. In case of process management, we have seen deadlocks, IPC, process synchronization, critical section process. Then we have started with memory management techniques, and finally, we have seen disk scheduling algorithms and disk scheduling criteria. So with this, I will conclude operating system subject today. Tomorrow, we will start with 8 to 11 C++, and I think tomorrow you have a data structure in the afternoon. All right. So hope you all have understood the basics of operating system. As far as your CCAT is concerned, you can go through the notes and the PPT slides which I have given, or the diagrams. But if you want to refer more, you please refer. There is a book called as Galvin Book by Operating System, which is very good book. You can go for it. Okay. So with this,